You guys want to try this one on your own? At least try to do it on your own. Don't be afraid of being wrong either. Try it. Think about it. You might actually find that you like it. It's problem solving can be, I hate to use the word fun, but it can be. It can be fun. So try to find a formula that generates any term. You plug in 3, it generates 10. You plug in 4, it generates 17. You plug in 5, it generates 26. By the way, if you can come up with a recursive formula, that's bonus points. Not that you're getting any points for this, but it's a recursive formula would be how would you generate the next number in terms of maybe some of the other numbers, one or more of them. Here's a hint for the recursive formula anyway. Find the successive differences between each term. See if you see a pattern there. So in other words, take 5 minus 2, see what you get. Take 10 minus 5, see what you get. 17 minus 10, see what you get. See if you see a pattern there. It's not the answer to the explicit formula, but it can get you a recursive formula. What were those successive differences? 3, 5, 7, 9. Oh, could you predict what the next one is? The next successive difference would be 11, right? Successively larger odd numbers, it looks like. So could you use that 11 to get the next number in the sequence? What would it be? So you add the successive difference, so 37, yeah. And if you like recursive formulas, you can keep going, right? Because what's the next number you're going to add? 13, right? Which would get you what, 50? But what's the disadvantage of that sort of formula? Yeah. If I ask you, hey, what's the 100th term? You got to find the first 99. In case you're not sure, that sucks. That would not be fun. I'm pretty sure you were sure about that. So, but that doesn't answer what the explicit formula is, right? That's the one we want. Well, I'll tell you a hint. Whenever you see this pattern of adding successively larger odd numbers to get the next number in the sequence, it's associated with, and it's been so long since I studied this, I don't remember why exactly, but it's associated with squaring. It's associated with squaring. So I'll bet if we manipulate, now I'm going to have to erase all this stuff, but I'll bet the general explicit formula will involve some manipulation of n squared. And with that hint, I'll bet you can get it. What do you got to do? Add 1 to it. How do you test it? A1 would be 1 squared plus 1, which is 2. Hey, look at that. A2 would be 2 squared plus 1, which would be 5. Hey, look at that. And then, you know, it works, right? A3 would be 3 squared plus 1, which would be 10. It works. Another line of thought that some people realize is, oh, they just subtract 1 individually, going backwards. So if you subtracted 1 from each one of these, you can see that you generate the perfect squares, 1, 4, 10, 9 actually, 16, 25. And then you go backwards to get the addition of 1 to the general formula. That one was definitely harder, right? But a couple of tricks to help you get through some problems like this. It's not going to be identifying explicit formulas, not going to be a huge deal in this class, but you should be able to do ones like the examples now.